Hey everyone, for so long we've pictured AI as this super smart brain that just deals with text, right? Kind of floating out there in the cloud. But what if that brain all of a sudden got eyes and ears? That's what we're diving into today with Google's Gemma 4. This is where AI gets senses. Seriously, just pause and think about this. What if the AI living on your phone or your laptop could literally see the world through your eyes? I don't just mean seeing pixels. I mean really understanding what it's looking at. Imagine the possibilities. What would that even unlock? Yeah, because we are way beyond just identifying, cat or dog in a photo. We're talking about something like this. An AI looks at a web page, and it doesn't just see a picture. It understands it's a user interface, it knows what a button is, and can literally pinpoint the exact coordinates of that view recipe button. That's a completely different ballgame for how we can interact with technology. So yeah, a feature like that, it's part of a huge, huge leap forward. What we're looking at here is Google's new family of models, Gemma 4. And it really is a new kind of AI. It's not just about being smarter with text. It's about being aware of the world. Okay, so what's the big deal with Gemma 4? What really makes it special? Well, let's break it down. First off, it's truly open. We're talking an Apache 2 license, so developers can pretty much go wild with it. Then, it's truly multimodal. It gets images, text, and audio. It's also super high quality, just crushing the benchmarks. And maybe the biggest thing? It's made to run everywhere, including right on your own devices. And listen, this isn't just one single model. No, it's a whole family. Google's put out a whole range of Gemma 4 models. So there's a perfect size and power level for basically anything you could think of doing. So here's the lineup. You've got these smaller, super efficient models that are perfect for everyday tasks right on your device. Then you've got the absolute beast, a 31 billion parameter model for the really heavy lifting. And there's even this clever mixture of experts model, which is kind of like it only uses the specific part of its brain it needs for a task, which makes it incredibly efficient. Having this whole range is what makes this so huge. It makes this powerful AI accessible to everyone, from giant server farms all the way down to the phone in your pocket. Right, so how does it actually do all this? What's the secret sauce here that makes Gemma 4 so powerful and, so efficient at the same time? Well, it boils down to a couple of really smart ideas in its architecture. The first big one is something called per-layer embeddings. You'll see it called PLE. And the core idea is pretty simple, actually. It's all about giving the AI a bunch of little hints to guide its thinking, instead of just one massive instruction at the beginning. Let me give you an analogy. Imagine you're building a complex Lego set. Most AIs get the entire instruction book, all 300 pages, dumped in their lap at the start. It's like, here you go, figure it out. But with PLE, it's different. It's like having a guide who at every single step whispers a tiny, perfect hint. Okay, now find the small red piece. See? It's a small nudge at every layer of the network, and the result of that is just a much smarter, more focused, and way more efficient model. Okay, trick number 2. It's called the shared KV cache. And this one is pure genius, all about being efficient. The idea is so simple it's brilliant. Just stop doing the same math over and over again. Basically, the later parts of the model can just grab and reuse calculations that were already done by the earlier parts. By not repeating itself, Gemma 4 slashes the amount of memory and processing power it needs. And that is the absolute key to making it possible to run a model this powerful on your local device and letting it chew through huge amounts of information without, melting your phone. All right, that's enough of the how it works stuff. Enough theory. Let's get to the fun part. The really exciting stuff. Let's actually see what this thing can do now that it has senses. Okay, let's start with a simple visual test. The task is, find the bicycle in this picture. Now, watch what happens. As we go from the smallest model up to the biggest one, you can literally see the bounding box get more and more accurate. It's a perfect way to see how the model's skill just scales up with its size. But look, finding objects is one thing, true understanding is another. So check this out. They gave the big 31B model an image and just said, describe this. And wow, look at this detail. It doesn't just say a seagull on a post. It says it's a high-angle, medium shot, that it's in Venice, Italy, and it even notices the yellow bus in the corner with the word Ferrovia on it. I mean, that is just an insane level of detail and nuance. Okay, so it can see. What about hearing? Well, here's a transcription from an audio clip. It is perfect, just flawless. It nails the punctuation, it gets the flow.
Gemini 4 can just listen and write down what it hears with stunning accuracy.
And honestly, the list just keeps going. It can understand video, it can generate working code just by looking at a picture of a website, it can even use other tools and functions based on what it's seeing or hearing. The sheer range of what it can do is, well, it's kind of staggering.
So this all leads to the big question, right? How do people actually get their hands on this and start building with it? Well, the awesome thing about Gemma 4 is that it was built from the ground up to be used by developers, like, right now.
And I mean right now. Gemma 4 launched with day one support for all the big open-source libraries that developers already use and love. We're talking Transformers, Llama.cpp, MLX, you name it. So whether you're coding in Python, Rust, JavaScript, C++, whatever, it's ready to go, out of the box. It just proves how serious they are about this being open and accessible.
And get this, you can even teach it new skills. The whole model is designed to be fine-tuned. There's this incredible example where developers taught it how to drive a car inside the carless simulator. The model is literally looking at the simulated road, making decisions on steering and speed, and then learning from how it does. I mean, that's it. That's the future of interactive AI right there.
So, when you put it all together, what's the big takeaway? The bottom line is that we are looking at a massive jump in performance. This is pushing the boundary of what we thought was possible, especially for AI that can live and run right on our own personal devices.
And if you want to see just how big of a jump this is, look at these numbers. This is a benchmark for visual math problems, right? The last generation, Gemma 3, scored about 46%. The new Gemma 4? It scores over 85%. That is not a small step up. That's not an upgrade. That's a flat-out breakthrough.
Which brings us right back to where we started, to the most important question of all. Because this tech, it's not a someday thing anymore. It's not a thought experiment. It's here. It's open for everyone to use. It's accessible. And it is wildly powerful. So I'm going to leave you with this to think about. When your devices can finally see, hear, and understand the world just like you do, what are you going to